Hi and Assalamualaikum. Today we will present about our group assignment they have given by lecturer Calculus-BEV10103. Before we go further, let me introduce our group member first. Me, Mohammad Syaifuddin bin Asli, number metric AE 220004. My friend, Muhammad Hannan bin Abdul Samad, AE 220121. And last, Ahmad Solehein bin Muhammad Radzi, AE 220021. We are from Section 2, Group A.
Okay, so this is our topic outline, which is consists of problem statement, introduction, our MATLAB simulation, and our manual calculation, and also our conclusion. So let's take a look at the first one, which is the problem statement. So solving the problem by using MATLAB software, which is MATLAB is a programming platform designed specifically for engineers and scientists to analyze and design systems and also products that transform our world. The heart of MATLAB is the MATLAB language, which is a metric-based language allowing the most natural expression of computational mathematics. So for our assignment, we are asked to derive and find such as voltage, power, and also the energy based on the equation given, which is current equation.
Assignment, we use MATLAB software to help us on how to solve any differentiation and integration by coding. It has so much advantages such as we could set any values by ourselves and then it would show us the result along with the graph so we could deduct it vividly. Moreover, the software MATLAB had already been subscribed by University Tun Hussein in Malaysia, which is to give a problem-solving assignment question for its students. Also, the question given were also quite high level, especially for students among universities levels. Most of the question given is practically based on electrical problems, as it is in our course. So it will open our eyes that coding could be one of the solutions that can be taken as a future engineer. This implies on the importance of coding to electrical industry in future.
Okay, now let's take a look at question one for the MATLAB script. So it is given an equation in 5 millihenry of an inductor. So the question A asks us to plot a graph of the current versus time. So the first thing that we need to do is identify which one is the one that belong to x-axis and which one is belong to y-axis. And then after we identify, time belongs to x-axis and current is belong to y-axis. So the first thing first, we need to define the time range and the step size for the x-axis, which is t minimum equals to 0 and t maximum equals to 1 and the t step equals to 0.01. So we need to generate the time vector by the equation t equals to t minimum, t step, and t max. So this is the given equation, which is the current equation, I equals to 2t power of 3 plus 4t. And then the last one is to plot the graph. We need to do the as this stated there, the script stated there, which is plot t1 x label, which is the x-axis belongs to time, with the unit s, and also the y label current with the unit ampere a. And also we put grid on to use the grid in graph. Okay, now for the second part of the question 1, which is question B, find the voltage across as a function of time, plot the graph of the voltage versus time, and calculate the voltage value when t equals to 50 milliseconds. So the first thing that we need to do is define the inductor value because it will use in a voltage formula. So same as the first question, which is we need to define the time range and step size, generate time vector, and also calculate voltage through an inductor using the formula V equals to L times with the current, integrate, differentiate the current. So voltage formula through an inductor is V equals to L times with 6t power of 2 plus 4. So for plotting the graph, which is time to voltage, we use to command plot TV, x label time as the title of the x-axis, and y label voltage V for as the title of the y-axis. So we also use grid on for the usage of grid in graph. So after we run our program, so the output of the graph will be as the below. So to find the voltage when t equals to 50 millisecond or equals to 0.05 second, so we just zoom in the graph, and then we will get 0.020076 as the answer of the voltage when t equals to 50 millisecond. Okay, for the last part of question 1, which is question C, find the power, plot a graph of the power versus time, and determine the power when t equals to 0.5 second. So the first thing that we need to do for the command is we need to define the inductor value, define the voltage equation, define the current equation, and also define time range and step size. Also generate time vector, calculate the power using the formula of V equals to V times I, which is voltage for V, and current for I. So the answer is P equals to 2t power of 3 plus 4t times with 3t power of 2 over 100 plus 1 over 50. So when plotting the graph, time versus power, so you need to use command plot TP, and then for x-axis level, which is time, the unit is S for second, and y-axis, the title is power, and the unit is W for watt. And we also use grid on for the usage of grid in graph. And after we run the program, we will get this kind of graph. And then to find the power value when t equals to 0.5, so we just zoom at the graph and click on 0.5t. So the power will appear there. It is 0.051875
The coding for 2A is you put SY and S, T, and then to define the time range and step size, you use T minimum equals to 0, T maximum equals to 10, T step equals to 0.01. And then the coding to generate time vector is T equals to T minimum, double dot T step, double dot T maximum. To calculate the current milliampere, you use the formula I equals to 5t times exponent in bracket negative 3t. That is the current equation based on question. And then the final one for 2a is you plot the graph current versus time. You plot ti, the coding is for the current versus time, and then the x label time, the title of x-axis, y label current milliampere, the title for y-axis, and grid on for the usage of grid in graph. For the next question, 2b, you put the same as before, sy ms equals t, c equals to 1 over 100,000 to define the value of capacitance, and I equals to 5t times exponent negative 3t to define the formula of current, and I naught is equal to 0 to define initial value of voltage. Okay, the coding for to define the time range and step size, you use the same coding as before, but you change only the value. T minimum equals to 0, T maximum equals to 1, and then the T step equals to 0.01. And then to generate time vector, you use T equals to T minimum, double dot T step, double dot T maximum. And then to calculate the voltage, you use the formula 1 over capacitance times INT I, and then plus V times 0. V equals to 1 over capacitance times negative 5 in bracket 5 exponent 5 times exponent negative 3t times 3t plus 1. You close the bracket over 9 plus I naught. For plotting the graph, you use plot TV to time versus voltage graph. So the x label is time, the title of x-axis, y label voltage is the title of y-axis, and then you use the grid on for the usage of grid in graph. For question 2c, C equals to 1 over 100,000 for capacitance value, I5 equals 5t times exponent negative 3t for current function, V equals to 1 over capacitance times negative 5 exponent times negative 3t times 3t plus 1 over 9 plus I naught for voltage function. I naught equal to 0 for initial voltage. Then for time, T min equals to 0, T max equals to 1, T step equals to 0.01. Then to generate time, T equals to T min, T step, T max. To calculate power using P equals to VI, the answer is negative 2,500,000 T times exponent negative 60 times 3T plus 1 over 9. To calculate energy using E equals to PT, negative 2,500,000 T times exponent negative 60 times 3T plus 1 over 9 times T. So if you look at the graph, the X and Y, the X value is negative 0.3 and the Y value is negative 7851.7. So when plotting the graph time versus energy, plot TE time versus energy, X label time, title of X axis, Y label energy J, title of Y axis, grid on for the usage of grid in graph. Thank you.
Alright, for the calculation part, question 1b asks to find the voltage V equal to L di over dt. So we are using that formula. We differentiate the equation first. Di over dt will get 6t the power of 2 plus 4. And we substitute the equation and we get 0.020075 volt. Next, to find the power. To find the power when t 0.5 second. So we have the formula which is P equal to V such V which is 0.0275 and I 2.25. We multiply, we will get 0.061875 watt. Next, for the question 2. Question 2b asks to calculate the voltage value after t equal to 30 millisecond. So, we have the formula which is V equal to 1C integrate I dt plus V0. So, we use the by part integration and we will get 1.85.56 MV. So for T0, we'll get negative 5.55556 exponent 4 and T0.03 will get negative 5.53436 exponent 4 and different will get 2.212 millivolt. Next, for 2C, the question asks to determine the energy stored at the time t 0.3 second. So, we need to calculate the power first. The power we can use the formula P equal to VI. We substitute, we'll get P equal to negative 0.262 milliwatt. And we calculate the equation for the energy E equal to PT. We substitute on the formula which is P equal to negative 0.262 and T 0.3, we get negative 0.0785 millijoule. Alright, to conclude that, all the question above can be solved by any software if we know how to code it. The assignment should be a stepping stone for us to keep advancing in digital era and acknowledge this method. Furthermore, it also helps us to be more creative with our coding so that we can manipulate it easily to ensure the accurate answer.
Alright, I think that's all from our group. Thank you for watching and listening our video, and I hope you guys enjoy. Thank you.